Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the path sum problem. Given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. A leaf is a node with no children. So for example here we're trying to get to 22, so we get 5 plus 4 is 9. Plus 11 is 20, plus 2 is 22. So there is a path. There may be other paths, I don't know if there is in this case, but we don't care. If we find any, we're good. Here, we cannot get to 5. If we go 1, 2, that only gets us to 3. If we go 1, 3, that only gets us to 4. Neither of those is 5. Here, there is no tree at all, so we cannot reach the target sum of 0. Right, well, this is a binary tree problem, which immediately says to me this is a recursive problem. Yeah, so let's think about what the recursion might be. Basically, if we are at the root, or if we're at the root, and the sum is larger than the target sum we can give up. If we're at a node, rather than it being at the root, if we're at a node and the traced sum is already larger than the target sum, that's no good. Ooh, no, never mind. Ignore that optimization because the value can be negative, so we can get back, as it were. So if we're trying to get to 5 and we had 1 and 50, we could then also have a minus 44, and it would all balance out. So actually, ignore that part. If we get to a node with no children, it's a leaf, and the sum is incorrect, return false. If we get to a leaf and the sum is correct, return true. And if we're not at a leaf, try the left child. If that succeeds, great, return true. Otherwise, try the right child and return whatever that returns. So let's try this. In fact, if not root, return false. If the node we're looking at just does not exist, stop. If root left is none and root right is none, in fact no, I'm just going to change this check up here. If root is none, if the root is none, false. If root.left is none and root.right is none. Oh, I need to do this in a different function. Hang on. Def path sum helper self node target current. Okay, we'll call this total. So if the node is none, if node.left is none and node.right is none, total plus equals node.value. In fact, I want to do this either way, so I'm going to quickly move this up here. The total gets incremented by node.value. Return target equals total. So if we're looking at the 5, add 5 to the running total. LF node.left is not. Hang on. Left is self.pathSum helper on node.left target total. If left return true. So here the idea is the recursion. Well, I don't know. Well, basically the 5 alone isn't a leaf. So I'm going to go down the left, and if there's a way to make it down here, then I know there's a way to make it here, from here. So that's good. Else return self.pathSum helper, pathSum helper, typing is hard apparently, no.write target total. And in fact, because I only use left in one place, I can just inline it like that. So the idea is, if I'm nowhere, false, stop. Otherwise, increment the total I've seen so far, because I'm at least looking at a node. So I'm going to add that to my total. If the left is none and the right is none, this is the leaf case. What we want to do now is check, did we reach the right number? So if we went all the way down here, we didn't make the right number. We got to 27 when we only wanted to get to 22, so this will return false. Otherwise, what we want to do is we want to come back up. So this would be a left recursion from here, and it would say false. So we go into the else case, then we go down to the right. We were looking at a 20, and this would get incremented by 2, and that target is correct. So that would return a true, and that would bubble up the tree. So this one has an interesting property of that it will exit early, basically. As soon as it finds this, it's going to start returning true, and this, although it hasn't even checked the right-hand side yet, it doesn't need to because it checked the left-hand side and found a path forward. So it's okay. If we get all the way to the end, so we try here, we go here, this is a leaf, but the total isn't right. We go back up, we try the right, the total still isn't correct. So we're done. This returns false. So all we need to do is actually turn this, to kick this off, basically. So we're going to return self.pathSum helper on the root with the target sum starting from 0. This structure looks an awful lot like what's called a fold, which is where you apply a function to every node in the tree based on the node value plus the fold of the left plus the fold of the right. The reason we don't explicitly just code up a fold function for this is because we want this early return behavior, this shortcut basically. We don't want to have to compute the right hand side before we decide whether we're done. So you might be clever and think this is a fold. We can do a little better than just being a fold. We want to fold with early exit. So we write the recursion by hand. Now, I was skimming down here. There is a small chance that this will fail, and that's because the tree can have up to 5,000 nodes. If those 5,000 nodes are one long chain, this will break because Python has a recursion limit of 998-ish, something like that. However, that seems like an awful trick to play on an easy problem, so I really hope that's not the case. Let's run the tests, see if I've made any silly typos. I have, because it's not node.value, it's just node.val. Try again. Excellent. All the test cases. I clicked the button too quickly. So we're expecting a true, a false, and a false. And that's exactly what we get, a true, a false, and a false. I wonder if there's any edge cases I've missed. Let's find out. Da-da-da-da. Excellent. So, as we learned yesterday, I'm not going to put any stock in these numbers whatsoever. It seems to be basically random. Not to mention this runtime is so short that it's almost entirely dominated by the Python interpreter startup. we found basically the solution for this. If we were truly worried about Python's recursion depth, obviously, one, we can just increase it, or two, we can actually rewrite this to use basically a list as an explicit stack. But that's far more than this kind of problem needs. If you're really that worried about it, you'd be using a different language. Anyway, that's it from me today. I do hope you enjoyed the video. If you did, remember to like, comment, and subscribe, all that good stuff. It really does help the YouTube algorithm know that you like my content. I've been away for a couple of weeks, and basically it has decided I don't exist anymore. So do show the algorithm some love and like, comment, subscribe. That's it from me. I will see you all next time. Bye.